Welcome to Coding Adventures. Today we are taking a deeper look at functions, and more precisely we're gonna see how to pass functions around as data. Let's get started. So I'm back here on my computer, and the way I'm gonna present this concept on how to pass functions around as data is via a series of examples. All right, so let me start with the first example and actually define a pretty simple function that we defined countless of time before. So the function will be named add, and this function takes two parameters, an a and b, and we're gonna return the sum of numbers. A very basic function indeed. Now, how can we invoke this function? Well, we can simply invoke it, put in the function name here, and between parentheses passing some arguments, just like that. Of course, we're gonna have to take the result in a variable eventually, and then display that one. So let's do that. And let's display it. And this is basically something that we discussed many lessons ago when we discussed about functions. As you can see, we have here number 5. But today we're gonna take this exercise one step further. And actually, I'm gonna show you that this function here that we defined using this plain syntax, using function and add and parameter and so on, we can manipulate it like any other piece of information that we usually store in a variable. As a matter of fact, let me show you that we can store this entire function in a variable, or more precisely a reference to that function in a variable. So let's define a variable here on top. Maybe perhaps we should call it add numbers, and it's a regular variable. Is the kind of variable that normally, would assign the number, or perhaps we'll assign a string like that. But instead of assigning a number or a string, this time we're gonna assign that function. The way we're gonna do that is just putting here the function name. Simple like that. Exactly as it appears here, same casing. Don't enclose it in codes. If we do that, it means we have a string. We don't want that. We just want to put the function name. All right, so this instruction, although it looks familiar, it's still new. What we have after executing this instruction in add numbers, we have basically a reference to the same function as add. And as a matter of fact, we can use the new name add numbers instead of the previous one. All right, so let's go in the next line here, and instead of add, let's say add numbers. We just use add numbers like any regular function. We put the name numbers. I had a typo there. We put just the name, and then we pass the arguments, similar to how add numbers would have been defined here. So let's try to run this example again, and notice we have the same result. It's not surprising, but it's a very powerful concept. This ability to take a function in a variable, and then once we have it in a variable, we can pass it around, we can pass it as arguments to other functions. This is a very powerful concept in JavaScript. All right, let me save this one. Function data1. And I'm gonna paste this example on the chat and continue with more examples. Data1 is on the chat. So perhaps we should take a few more other examples and play with basically these functions, right? All right. So what I have here on my desktop, I have a series. Let me open this file. I have a series of commands to say like that, but actually I have 3 drawings. Drawn using the plain simple shape commands, the one that we encountered many times in the past. So let me just perhaps copy the entire text, not by one, but the entire one. We don't have the need for this one, and let's place it inside here. Now, of course, if we want to execute this program, let me just keep just the first part. If we run it, we have a car here, or if we run the second, the other ones, we should see a flower and a boat. That's the idea. We have 3 drawings drawn like through a series of simple shape commands. Let's first encapsulate these drawings in some functions. So perhaps the first one should be called function car, and it opens there and closes here. This should be function flower, and we use the plain regular syntax, the one that we used until now up to this point, and this one is function boat. And bear with me just a second, I want to run this one to make sure that basically our program doesn't have errors. It's always good to test it from time to time to avoid accumulation of errors. Car, looking good. Flower, looking good. And the last one is boat. Alright, all three looks good. Now, what I want to do is basically, first of all, use the concept that we discussed today, but I want to kind of achieve an effect like one of the images is displayed for a couple of seconds, then the next image is displayed, and the third image is displayed. And the way I'm going to do that, I'm going to define basically here an array. So let me define an array, drawing functions, drawing funcs. And I'm gonna put inside the actual names of the functions: car, flower, and boat. There is nothing to stop us. If we are able to take a name of a function in a variable, we can very well put it inside an array. So at this point, we have an array of three functions: car, flower, and boat. All these ones, car, flower, and boat, basically refer to the same functions that are here, but this time are inside an array. So let's see how can we basically display it in a loop. I'm gonna write the logic pretty quickly because basically this should be pretty familiar until now. So let's say we have a variable here, current func, that is 0. We have a variable that points at which element in the array is the current element, and then we're gonna define the function loop. And inside the function loop, we can issue a clear. And then how can we basically, in order to display one of the drawing, we need to execute it. So how can we execute that particular element of an array? Well, one way of doing it is just, first of all, how can we access an element in an array? By index, of course. So the way we're gonna do it, we're gonna access it like that. This is an element inside this array, right? So perhaps it's much easier to take it in a variable. Let fn. We know already that it's a function, so we name this variable fn. And we take in a variable the current element inside this array. And then we're going to execute the function fn, open parenthesis, close parenthesis. Notice fn is not defined as a function again in code here. There is no function fn defined. Fn is just a variable that was assigned this particular function inside the array. But since it's still a variable, we can invoke it using the regular function invocation syntax with parentheses, just like that. Right? So right now we can run it, but basically we need to also increment this current function in order to see the next one. But just for the moment, let's run it. All right, we can see the first image being displayed, which is perfectly as expected. So our syntax of accessing the element in the array and basically accessing that function works perfectly. We invoke that function and works. Let's now work on the logic to basically advance the drawing to the next one, right? So what we can say is if frame count, it's basically divisible with 100. So basically every 100 frames, what we can do, we can increase the function. And then we can also check if we can increase the number that points to the function. And also we can check if this one is bigger than the drawing funcs.length. Then of course it will become 0. All right, so let's run this small program. We have the car, we have the flower, and we have the boat. Oops. And the program repeats here, fn is not a function. Right, So basically, here we should check if greater or equal than function length, because it's zero-based array. We have the car, flower, boat, car, and so on. And now the program should repeat. You know, although it's a nice, interesting effect because of the drawings, the main point behind this exercise is that we use these functions as data, as variables inside an array or elements inside the array, an array of functions. So let me save this one. So this one is array of functions. And maybe I should put 1. I want to show you something as well with this one. I'm gonna copy it. Let me put it on the chat. Array function 1. All right. So let's look a little bit at the functions here. We just come back to the main functions, the car, the flower, and the boat. And I want to show you another way to define functions in JavaScript. Although this one is pretty common and basically should cover majority of situations, let me show you another way to define functions, and that's using an expression formula. So instead of saying function car here, what we can do, we can take in a variable directly. For instance, we should name this car function car. And I can also put the bracket here at the end, like I mentioned, more advanced programmers used to do. Let me do the same with the other ones. Let flower equal. Let me put this one as well here. And this one as well. Let boat equal. So I took in a variable the entire function expression with an equal sign here, exactly like we are assigning a number to a variable. Now, because we have this variable, this one becomes optional and is not needed. So what we can do, and it's always recommended to do that, remove the second one, right? So we don't have the name of the function there, but we have what is called right now an anonymous function. This is what is called an anonymous function, and this one gets assigned to a variable car. But because it gets assigned to variable car, we can use it in the same way that we used until now the function car. And in a sense, in JavaScript, this is another way of declaring functions. There are some small differences between them. One of them, our program will not run if we'll try to run it now. And the reason being, in the moment we define functions using expressions, so in this format, these have to come in order. So notice here at the beginning, our program makes use of car, but car is no longer defined. All the let statements, as you know, they need to come in order. As before, when we had the former syntax with function and then the name of functions, because of that ability of JavaScript to hoist things at the top, how it's called, we could have functions at the end. But now it's a mandatory to have them in order. So let me move this at the beginning of the script for now. I'm putting them there. So they are like three simple assignments at this point. And then we have the rest of the program that make use of these variables. So let me save a copy actually. This was because I don't want to override the first one. And let me run it. And the program should run as expected again. So we're gonna inspect again the program. Let me minify a little bit perhaps these bodies of functions just to see them more, to see them better. So the syntax is like this. We define like a variable. We can use const. Actually, const is much better in this kind of situations because we don't plan to change the value of car. So we say we define a variable. We can use let or const, and we say equal function. We don't put the name of for the function, and then we put the body of the function here. As expanded, it looks like that, right? But remember, when we are using this syntax, the statements, they need to come in order before they are used. So otherwise it's not working. So this is a difference from the other way of defining functions. So this is working fine. Let me share this one with you on the chat as well. So this should be basically array function 2. the main body here remained unchanged. The only difference is that right now we define the functions using this expression format. And actually, you know, since I want to show that these functions are so flexible and exactly like a piece of data, here when we define an array, here we see that we have 3 variables and then we put them inside the array as elements. We can actually put the entire body of the function inside the array here. We don't have to have them as variable. So let's do just that. Let me save a copy. Perhaps this is number 3. And what we're gonna do, let's look at this array. And what we want to do, instead of putting actually the variables inside the array, we're gonna put the entire body of functions. So I put an enter there because these are bigger, so we'll need the space on vertical. So let me take the first one, and we'll go instead of car. Exactly like we'd put here a number, right? But instead of a number, I'm just pasting this entire expression, just like that. And take the second one, flower, and I'm pasting this one as well, and take the third one, boat, and instead of the boat variable here, I'm pasting this as well. And now we can even remove these ones, they are not needed. So let's look at this big array. Of course, perhaps it's not practical to do this in this way, but in certain situations it's quite okay to just use them in line like this. Notice the functions, they don't have any name, but not we need any name actually. We don't need any name for this function. So we basically have an array with 3 anonymous functions inside. They don't have any name. We cannot refer to them by name, but since we're gonna refer to the elements of the array by index, we can basically invoke the functions that way, even if we don't know their names, because they don't have any meaningful name. So let's try to run it, and the program should run as expected again. So the syntax takes probably a little bit of practice and time to accommodate with this kind of new syntax, but it's not that difficult and not that different from the one before. We just remove the name to have this as anonymous, and we just passed around the functions. But it gets even more weirder, to say like that. Let me save another copy. Oh, yeah, actually before that, let me put the copy tree on the chat. Yeah, we don't have it on the chat. Let me have it on the chat here. All right. Array function tree. And now I'm gonna save a new copy. And this one I'm gonna name it array function 4. I'm gonna save it. And I want to show you basically with this one another way in which we can define functions. And this new way, this way is a little bit newer in JavaScript. It was introduced in the recent versions of JavaScript. And that's basically what it's called a lambda expression on arrow functions. And why arrow? Because you'll see we use a symbol that looks like an arrow. Arrow, sorry, not arrow. We don't want errors in our programs. So let's pay close attention to the first function here, and let's convert this anonymous function from this classical syntax in an arrow function. The way we're gonna do that, we just remove the keyword function altogether, and we go in between parentheses and curly bracket and put an arrow or an equal and greater sign. All right. Let's do the same with the other ones, and then we'll take another look at those. So let me remove this function again. All right, so you may wonder, what do we have now in an array? We still have 3 functions. These functions have a little bit of a different syntax this time, where they are defined using this arrow syntax. It's parentheses, arrow sign, and then the body of the function. And as you can probably hint, if the function takes parameters, we can actually put them inside here like this. But since these functions, they don't take parameters, we just leave the parentheses empty. But nevertheless, at the end of the day, we still have 3 functions here inside. There are small differences though between this kind of arrow functions and the functions defined using the other syntax, but these are beyond the scope of this exercise for today. Let's run the program and see if it does the effect. And it's the same. All right. That was quite a journey. We took this exercise from very simple code to this kind of weird looking new function definition inside of a big array. What a funny array. Let me save this one on the chat as well. And perhaps we should do a little bit more simpler exercise this time. Array function 4. And the program is there on the chat. So let's perhaps create a very simple function that will start it from scratch, will not have arrays this time. Let's create a function. Remember the function that we created initially to do the sum of 2 numbers. This time we're gonna create a function that will accept as parameter another function. So since these functions are data, we can basically pass them to other functions as arguments. So let's create this function and call it calculate. And this function will take first of all 2 numbers, a and b. And we can stop this function here and we perhaps can return a plus b. Something like that. So basically this will be basically identical to the add function that we defined before. But instead of actually doing the sum, or if we want another function to do the product, we have to just copy it and duplicate it and have a function to do the product. Instead of doing that, we're gonna pass here as an argument another function. Let's name this function compute. So it is expected actually that the user of this function will pass an argument as the third argument into calculate function, a function that will basically tell what he wants to do with the 2 numbers, right? So, and then in this case, our calculate function will not do the sum, will not do the product, but will actually make use of this function that is passed as an argument and return the result of that function, right? It's a simple encapsulation this time, perhaps too simple. Calculate just calls the function, but perhaps, in a more complex example, it can do other things and then at the end invoke this one. But nevertheless, let's say somebody defines this function and asks us to invoke it. How can we invoke such thing, right? So let's see it first of all. If we try just to invoke it, let's say let result equal calculate. First of all, we should the first 2 parameters, we pass them in this way, right? But what should we pass as the third argument here? And we can use basically like we used before, a function. We can even define it here in the code and pass that one, or we can basically just use it an arrow expression. And let's see both kind of examples. So first one, let's define a function here, add, that takes 2 numbers. Notice here, the function that is passed to calculate, it is expected that the user define this function and make it in such way that accepts 2 arguments. So we don't have any choice but actually define this function and make it accept 2 arguments, and inside we do whatever calculation we want. Perhaps we want to add 2 numbers. And what we can do now, we just pass the function here, putting the name of the function. Again, no codes, just the name of the function. All right, so let's print the result and see what we are getting. We do print result, and if we run it, number 5. We created an overcomplicated example just to calculate the sum of 2 numbers. But perhaps this function is in a library and we don't even see it, right? So somebody says to us, okay, in order to do this calculation, you have to basically invoke calculate, pass the numbers, and then pass a small function that will tell it how to do the calculation. So you can even create additional functions such as multiply, and basically, if we just replace here add with multiply, oops, and if we'll call it, now we should get the product of the numbers, right? So something pretty simple. How can we express, instead of add or multiply, how can we basically define this third parameter? And we said we can use an arrow expression. And the way we're gonna do that, we're gonna basically, let's say we don't see this function, it's still at the bottom there, we don't see it. Let's use a lambda expression or an arrow function. And the way we're gonna do that, we're gonna define it here in line, just like this. And as this arrow expression will, since this one takes arguments, we'll put them in between parentheses, and then here we can say return a plus b, like we did before. And if we run it, we still get number 5. And when you have lambda expression this simple with a simple return here, you can actually omit the return altogether. And if we run it, let's see, yeah, if we'll run this expression, oops, I have an error here, a plus b, and we have 5. And you don't even have to put the other kind of curly brackets if you omit the return. So it's just simple like that. This, as simple as it looks, it's still a function. It's an arrow function that if to write it separately, you'll just say function, takes argument a and b, open curly brackets, and then put a return a plus b. But we can also express it in this very, very concise form in this way. All right? And we still have the result. So basically, what we achieved in this exercise, let's look again at the exercise. We created a function that takes some numbers and also takes as an argument another function. And then we also looked on how to invoke this function, passing as the third arguments an arrow expression or an arrow function expression, a lambda expression that can basically produce the result. And we saw before that we can actually pass a regular function if we define it here in the body, or like in the previous exercise, we could just define it here as well. Just like that. For the moment, I'm just writing how we can define this one as well in line here. Function AB, and it's an it's an anonymous function, returns a plus b. If this one will run it, we still works. So perhaps we should keep this one. So this is one way of doing it, and the other way of doing it that we basically said was using the arrow notation. So let me put here the arrow notation like that, right? So if we run it, we still have 5. Oh, we don't even need the parentheses around a plus b. So pretty concise, a little bit cryptical probably for new code newbies that see this syntax. Fortunately, it's a little bit of a more advanced syntax, but nevertheless, it's still used in modern JavaScript. And depending where you are using JavaScript, you may be kind of in deeper need of learning this kind of arrow functions. Some frameworks favor more in particular this kind of notation. So if you're working with those frameworks, you just to put a name, React or some other frameworks, you'll probably have to use this kind of notation. And there are a few other benefits that nevertheless you can use them. All right, so let's create another exercise. First, let me let me save it, compute, and save it and share it with you. It's a very simple example, but just in case you are collecting this and if you want to study them further, it's good to have it there on the chat. All right, so let's create another example here. Perhaps we should do something a little bit more graphical this time. Let's create a function. Do you remember from last time when we drew those circles on a circle? Actually, let's locate that example and not start from scratch, but let's locate that example pretty quickly. And I think it's this one, is the one from last week. I'm gonna copy it in a new program here. We're gonna run it, right? We basically use the these trigonometric calculations in order to determine the x and y coordinates of these smaller circles, and we place them on a circle. Now, perhaps this logic is very complex, and it is, even in this form, it's a little bit more complex than usual. And you know, the downside of this function is that it draws only circles. What if we want now to have to draw small rectangles arranged in a circle? Well, you can say we can come here and we put a rectangle, and you know, if we'll run it, we have small rectangles on a circle, right? But what if we want to have both circles and rectangle on a circle, or decide the color? The user that uses this function wants to decide, perhaps I want circles, maybe I want to have rectangles. So let's put here, actually, let's rename one way to do it. Let's name this one shapes on a circle, shapes on circle. And right now it's with rectangle, we saw it before with circles. And what if we want to have it basically with, you know, with circles or rectangles? One way of doing it is basically to define, to pass another argument here, what to draw. And inside here saying if what perhaps is 1, we'll draw circles. So we'll draw actually circle and x and y and radius 5. We can say else if what equal to, we'll do rectangle, right? That's one way of doing it. And if we want to draw also triangles, we can extend this function. And as a caller, all we have to do is to pass here an argument. So if we are passing a 1, we'll draw circles. If we are passing a 2, we're gonna draw rectangles. Pretty easy, right? So, and if we want tomorrow to draw triangles, all we have to do is to come in the body of this function and put another else if, and say if what equal 3, draw triangles. And will work beautifully, with one exception. What if we are not the author of this function? What if a friend of us writes this function for us and places it in a library, and we cannot modify this function? We cannot even see it, right? Well, the function is there in a library, and we like the function, but it draws only circles and rectangles, and we really need to draw triangles. What we are doing in this situation, right? We can call our friend and it will send a new version of the function. That's one solution. But in certain cases, you know, that's not possible. Therefore, the authors of this kind of generic functions have to think ahead of time of these situations and perhaps design the function in such a way that will accommodate our future needs. What if we want to draw triangles? So let's see how let's put ourselves in the shoes of the developer of this function and see how can we design this function to draw basically something else, right? So the way we're gonna do it, instead of having this parameter as an what we can have is basically here, actually we can pass a draw function. Let's name this one fnDraw, function draw. And inside, we don't even need this kind of logic. All we are doing, we can invoke the function that we are getting passed. We are getting invoked for the x and y coordinates, just like this, right? Because all the logic that calculates the x and y are inside the shapes on a circle here. But right now, what's not inside is the logic to do the drawing of the actual shape. In other way, we decoupled the drawing from the logic to place the drawings around, which is very good. So let's see how we can invoke this one. Well, so let's say this one, it's in a library. Again, we don't see it. It's by function. So we are now in the shoes of a user that wants to use this function. Well, instead of 2 here, all we have to do, for instance, we can put a lambda expression and we can put an x and y, because that's the way we are supposed to basically pass this argument. And this one can do whatever drawing we want. So perhaps this drawing will do it, right? So if we run it, we have back the circles. And now if we want to have rectangle, we'll have a rectangle here. And if we want to have a triangle, we can have a triangle here. So it's up to us, the user of this function, to decide what shape we want inside. And this was possible only using this kind of paradigm. There are other ways as well, but this one works quite well in here. We are passing an argument shapes on the circle, the drawing function, and this one is responsible of just drawing one single element there. But the function will just invoke this one at the right time with the right arguments that calculates inside and achieves this effect, right? Perhaps even we can draw a car here. We can make a bigger function, and instead of having only a rectangle and a circle, you know, we can have multiple ones. So let me just put multiple instructions here. Won't be exactly a car, but you know, I hope you get the idea what we can do with this function right now. And if I run it, see, we have this small circle and rectangle for each of the points. And look how it looks right now. It looks intimidating or a little bit different. Again, if you are not familiar with this syntax, but you still want to play around with functions and take functions in variables and pass them around, use the other syntax. Let me type it here. Function my drawing will take an x and y, regular function syntax, and we'll put as body these two instructions. And let me comment for a second this one and invoke it again, the function, but this time instead of passing that weird looking expression, we'll just pass the name of the function, and if we run this, should do the same effect. So see, a combination of these two, it's similar to this single one here. And perhaps we should keep them both in the code here for the moment. I'm gonna leave this commented and leave the new version here. And let me remove the spaces. And I'm gonna share this program with you on the chat. So shapes on circle. All right, program is saved and is ready to be shared on the chat. Shapes on circle. All right. So as you can see, it's pretty powerful. This concept of having functions as variables and passing them around and putting them in arrays and taking them out from the arrays. It's such an important feature of JavaScript and very, very powerful. So perhaps it's now time to recap on paper on basically what we saw until now. So let's write here. So first of all, we saw that we can take a function in a variable, right? So if you let's do just that. If we have a function, let's say function is called add, like we had it exactly this particular example. This is a plain regular function. What we can do, we can take in a variable, for instance, add2. I'll just name it add2 to save time, equal add. Just like that. From this point on, we can invoke add2, similar to how we basically, you know, we invoke add. Notice we are invoking add2 here, which points to add, which basically points to this one. So that's one way of basically taking functions in variables. What we also saw today is that we can have functions that takes basically other functions as arguments, such as we had that case with function calculate. And the function calculate took basically two numbers as an argument, and the third argument there was a function, fn, right? So inside here, because this one we know that it's a function, we'll just invoke it like that. Now, what is happening perhaps if the caller, instead of fn passing a function, will pass a number or pass a string? Well, the program will produce an error on this line because it is expected fn to be a function, because this syntax is valid for a function. It means function execution. Each time we see open close parentheses means execute a function. So this is function execution. So we saw this one as well. What else we saw today? Well, we saw how to define functions as an expression, and basically we saw anonymous functions. So let's take in an expression here. Let perhaps add which is the one above here, we saw that can be also written as this, equal function. We open parentheses, we still takes the same arguments as here, we open curly bracket and close curly bracket. And I choose to put the curly bracket here at the end. I can also put it here, but I choose just to, to show you also this kind of a convention. So this is basically equivalent. So this whole expression is equivalent with the first one here, with the only difference that if we are using this expression notation for defining functions, they need to appear for sure before they are used. In this particular case, function can appear after they are used because they are just found inside the script by JavaScript through this mechanism of hoisting that we discussed in the past, of actually raising to the top those declarations. All right, and we saw one more other thing today, which is basically lambda expressions. And a lambda expression is also a function, so perhaps the same one here, let's also define it using a lambda expression. We can write it like this: let add equal, and we'll put AB, I don't have space inside here, and return A plus B, just like that. And we didn't actually took that a lambda expression in a variable until now, so we can jump in the code and actually take this one. We just use this thing that is here as a parameter to a function, but actually you can assign it to a variable, and this is a very, very valid way to define a function as well. So we have our first form that we use until now, we have the second form, which is anonymous function, and this is lambda. So this is anonymous function, and this is the third way, which is basically arrow function or lambda expression. All right, and then once we have a function, the second concept that we discuss is basically we can take it in a variable, or we can pass it as an argument to a function, we can add it in an array, we can do all those fancy things exactly like we are doing with a variable, with a plain variable. So let's also write here really quickly a program to have those functions defined with an arrow notation like we put on the paper, because we didn't get the chance to actually write them here. So let's define two functions, add and multiply, using the arrow notation. So normally let's write them normally first. They look like that. Return A plus B, and then function multiply A and B, you just look A times B, right? So we saw this one until now. Now what we're gonna do, we're gonna remove them and let's define them. Add equal, it's an arrow function that takes A and B and returns A plus B. Multiplication, it takes A and B and returns A times B. And the way we're gonna use it, we can say println, and we can use them as simple plus regular functions. Add 2 and 3, so we should see a 5, and if we are calling here mult, we should see a 6. So if we run this, 5 and 6, right? So pretty simple, right? This syntax above, it's has less lines than what we used to do until now. Some people find it easier to understand or to read, more human readable than the whole expression with function and open curly brackets. Other people, because it's so condensed, find it a little bit more hard to digest and still prefer the old expressions. But nevertheless, both concepts are pretty useful here. And yeah, so what we have here, we have two functions. All right, so I can save this one on the chat, or it's pretty simple program. You can try to reproduce it yourself here from the screen. So let's create perhaps a more complex example here. And let's create some sort of a graphical representation, also using this kind of functions. And yeah, perhaps we should have a function named add button. And the idea is that, let's say this function add button, it will basically place a button on the screen. Basically a button is a small rectangle. It's a fancy name, add button. But you know, the concept is from the GUI programming, when you have those buttons that you press. So we'll press this button on the screen at certain coordinates, certain width and size, width and height, and we'll do an action when you click this button, right? So how do you define this function? You are a library author right now, and somebody asks you, please do me a function that displays button on the screen, and it will let the users of the functions decide what action to run when the buttons are clicked. So this is basically the requirement or the request. So add button obviously should take an X and Y as an argument, right? Because we need to know exactly where to place the button, and perhaps we should take also width, and perhaps should take also text, what we want to display on the button. So until now, it's pretty simple. The only remaining part is these buttons need to be clickable. So when a user will click on the buttons, they need to basically produce an action, and we don't want to encode inside the button the actual action. We want again to let the user of this function decide what he wants to write when we'll click on one of these buttons. So we'll add this event or this kind of callback kind of, and callback, it's a proper name to name it, callback kind of action towards the end. Let's first now implement the regular plumbing to have these buttons appear on the screen and have some text on them, all right? Shall we? So perhaps the way we should do this, we should have here an array of buttons. So each time that we call add button, we should push a small object inside this array. So buttons, push, and we should push a small object, and the small object should have the property X, Y, width, height, and text, right? So each time we invoke the button, we'll do this thing. Very simple. And then what else? We should have a function loop here that will basically be responsible of displaying the buttons. And yeah, let's display the buttons here. So let's say perhaps we can even clear the screen all the time. It's not necessary, but let's say we clear the screen and we're gonna loop through all the buttons. Let btn of buttons. And what we are doing here, we need to display it. So we can call a display button. We can call a display passing a button as an argument, right? For each button. Let's define that function. Display takes an argument, button. And well, one way what it can do, we can draw a rectangle at basically these coordinates, btn.y, and then w and btn.height. So that's one way of doing it. Let's run it. Nothing happens. Oh, because we didn't add any button on the screen. So let's add a button at perhaps 10, 10, 10, width of the button 80, 20, and some text. Okay. And let's have two buttons actually. The other one is at 50 and say at cancel. Okay, and cancel, the typical buttons that you encounter in any applications, but let's place them on horizontal instead. So 150 here and 10. All right, so we have two buttons. What we didn't do is we didn't display the text inside. Too low. It doesn't matter. Anyway, let's display also the text. So we're gonna have a text. That is basically we're displaying the btn.text, and we're gonna display it at, we're gonna shift a little bit the coordinates. Cannot be at btnx and btny the way text is basically defined, but let's have here no stroke, fill black. All right. And do this one and this one, which basically should be fill black. And actually no, what colors are buttons? Gray, right? white smoke. It's a named color there in HTML that is recognized by JavaScript, white smoke. And stroke, let's have a nice border around them, perhaps black. And you know, if right now at this point we put enough effort, we can make really nice, cooling looking buttons, 3D buttons or flat buttons, modern buttons. But for now, we'll just have them like this. Right, so let's see why it's not displaying. Oh, because it's not called txt, it's called text here, yes. And we have to basically, well, there are certain ways in which basically new instructions we can decide where is the hotspot of the text. Right now, the hotspot is basically in the bottom left corner. We can put the hotspot in the middle, and the way we do that, we can use text align, which is from P5.js. Again, if you are not remembering this instruction, the graphical one, you can Google text align P5.js, and basically, you know, you should see the reference. So what we are looking for is text align center here. Well, this is a nicety. We don't have to do it right now. And then we are putting a btn x plus btn.y divided by 2, and this one is probably is btn.h divided by 2, something like that. I think it will be in the center. Yeah, or pretty close. So we have these buttons. They are not, you know, they don't push. We can take care of that as well if we want, but it's not necessary right now. The main point is here, how can we make them clickable, right? And first of all, inside this program here, what we can do, we can handle mouse press. Let's handle mouse press function. Mouse press. Mouse press will basically be used to detect if the mouse is clicked, and we'll need to detect if we are clicking one of the buttons. And basically, you know, the coordinate of the mouse is mouse X and mouse Y. So what we need to do is to iterate through all the buttons and check if, when we are clicking on the screen here, if basically mouse X and mouse Y, it's inside on one of these rectangle. And it's pretty simple formula to do that one. Let me show it to you really quick, although it's not necessary to do it. We have a built-in function, and we'll use the built-in function, but basically we can detect pretty easily. It's not difficult if a point inside is inside a rectangle. So how can you know if this point of X and Y it's inside this rectangle? Well, we know that the rectangle has certain coordinates. Let's say this rectangle has X and Y and has a certain width and has a certain h. So we need to verify if this point basically is between this coordinate and this coordinate, and also is between this coordinate and this coordinate. So that's all it takes. So if inside it is between those coordinates, it means it's inside the rectangle. But for this one, we have a pretty useful function here. It's called collision point rect, and returns basically it returns for us true or false. So it's it's under here. Let me locate the function really quickly. We don't have to reinvent it right now. We can perhaps, you know, just define these functions in a different exercise some other time. But this function will basically tell us if a point hits a rectangle, right? So okay, we said all we have to do inside here, we have to iterate all the buttons. Let btn of buttons, and now we have to check. Let's say is hit. We take in a boolean variable, in a variable that is true or false. Collision point rect. We verify mouse X and mouse Y. This is the point. We want to verify it if it's inside the rectangle. btn.x, btn.y, btn.w, btn.h. Right? So this variable will contain true. Is basically when we click with the mouse, if the mouse is inside that rectangle, and will return false otherwise. So therefore we can use a if here and say if is hit, it means okay, we hit it. So we have to do something. And for now we're gonna just print on the screen here. hit. Let's hit, right? And normally we'd put here the logic. So let's run it first to make sure that it's running okay. Hit, hit. If we click outside, no hit, but if we click inside, it's hit. So seems to work perfectly. And let me name this one UI buttons and save it. So now perhaps if we are developing a game and this is our code, we're gonna write here the code that basically happens when a button is hit. And there's not a problem about that one because it's our code and we can write here. But what we said, what if we ask a friend to develop this for us and we don't see this code? This code is somewhere, again, in a library. Our friend handed it over the library in a very cryptic format. We cannot edit it. And now we have to use it, right? So the way we use it, we'll say add button, but we cannot go inside that library now and write the logic. What's happening if we hit this button, or what's happening if we hit this button, right? So we need to tell our friend to design the add button in such a way that will allow us to basically pass a callback function, to say like that, to specify a function that is triggered when that button is called, such as it will be very nice for us if we have a function here, function OK, or say btn OK clicked, let's name it like that, or let's name it on btn. Sorry about all this mess with variables and naming conventions. On btn clicked, and we'll have another function on btn cancel clicked, right? So it will be really nice if we can link this function to this button. So when this button is clicked, this function will be triggered, and when this button is clicked, this function will be triggered, right? So of course we need to link them. So for us it will be convenient to pass here the name of the function, or to pass here the function. So we want just like that. And for the second one, we want just like that, right? So as a user of this library where the add button is basically defined, we basically want to use it, invoke it like that. So how this function needs to look from the perspective of the person that writes the function? Well, first of all, it needs to take here another argument, which is basically a function. Let's name this one, because we put the prefix until now fn on click. So as an author of this function, we say, okay, this function expects on this position, this number, it expects a function that is basically, we're gonna call it back each time the button is clicked, right? So, all right, so let's see what we have to do with this function, because this function is per button, is not a global one. So we'll, first of all, we'll have to store it with the rest of the parameters of that button. When we create this array of buttons, we store not only the position, we store also the event handler, or the kind of function that we need to call back when that button is hit. And now let's look into the mouse press event. If we are hitting that button, all we have to do, no complex logic here whatsoever, we just have to say btn dot, and this is the function name, and we are invoking it. Just like that, as simple as this. Again, this function is a property, notice here, it's a property of this object, and we are linking into the next lesson that we'll have tomorrow, that you can actually also put functions as properties of objects. So we have this function inside of an object, and we are now just invoking it, right? So let's actually, yeah, we don't need that white space, but I'm gonna put a separator here. This is basically the usage, and below is basically the implementation, the library code, and so on. So how can we know that we clicked? Let's just put some simple code here for the moment. Yeah, let's put a println here and say hit, and hit OK, perhaps, and this one hit cancel. like this, right? So if we run it, hit OK, hit cancel, and outside doesn't happen anything. Of course, here we can put some other code. Perhaps the first button should change the background background to light blue, and the second button should change the background to light yellow. Let's see it. Outside nothing, light blue, light yellow, light blue, light yellow, and so on and so forth. All right, so you see how powerful are this ability to take a function in a variable and pass it around. It opens new possibilities of the code. It enables, and what we showed in these past two examples, we basically showed how to decouple the implementation here, that the logic, exactly like we shown in that one with drawing shapes on a circle, we decouple the drawing logic from the logic of placing on the circle. Here we are basically decoupling, or we are allowing the user to specify what's happening at this particular point. And it's pretty common with many libraries to accept this kind of callback functions here as arguments. That's not the only way to do it, but it's pretty common with many libraries, as you'll encounter there. So the libraries will contain functions that take regular arguments, but you'll notice that some arguments expected are actually functions, and you are supposed to provide here a function. And for instance, the library will invoke back the function when certain things happen. In this particular case, is invoking it when a button is clicked, right? So let me share this example with you on the chat as well, and let's see more examples. UI buttons. All right, and now of course this is not a complex example, but if you are really into building an UI library on the canvas, feel free to go. You can build all sorts of widgets, and perhaps we should look into this exercise another time. Right now we focus on all these kind of functions. And here, of course, here you can also put a lambda expression. If this expression is kind of small, of course, you can also put a lambda expression here, right? Let me show you another example. This time, I'm not do the implementation. In the interest of time, we can do the implementation other time. I'm gonna just leverage the code that it's already written on this site. I located an interesting example that I want to basically show it to you. So let me just inherit a little bit of the code here really quickly. Which is basically this one. I'm gonna run it. You know, it plots a function. We did in the past, in one of the previous lessons, also a plot of the sine function. Our code was a little bit different than this one, but nevertheless, I want to show you something that this code has. But let me first simplify it here a little bit. Yeah. Right. All right. So if I run it, yes, we have a sine function, the graph of sine function. It's graphed by this function here. And notice how it's implemented. In the past, you remember we implemented a sine of plotting the sine function. We're graphing the sine function, and we did it in a way something like this. Function, graph sine, and between these values, and when we invoke it, we basically invoke it with 0 and 360, right? Now, what if we have to plot cosine? One way is basically to create another function and, you know, say graph cosine, and we can have it, right? But you'll see that when you are working on this kind of task, you spend a lot of time on the implementation. Look at this code here. It's not that big, but still has lots of calculations here inside, and so on and so forth. So if we went through all this effort to do the graphing of sine once, if we have to do cosine, we have to redo again the entire thing. And copying and pasting is also not a good idea, because we'll have the code duplicated, and if we have an error in one code, we have to fix it in both codes bases, and it's not good. But notice how is this one implemented. Instead of plotting or graphing the sine function, it's actually graphing any function, and it's passing the function that we want to graph as a lambda expression here on the first argument here. So if we want to graph sine, no problem. If we want to graph cosine, no problem as well. Is this one. We can even graph both if we want on the same graph. We'll just invoke them twice. And we overlap them, right? We don't even have to graph trigonometric functions. What we can graph, for instance, a quadratic function such as x squared plus 2x minus 3 or minus 5 or something like that. Let's put minus 5, and if we run it, we'll see the function here plotted on this interval 0, 360. Perhaps this one we should plot it on the interval minus 10, 10, and then we see the parabola associated with a quadratic function. So see, in order to plot different functions, we didn't have to change the code. All we had to do is to basically define the function that we want to plot as a lambda expression, or again, we can just take it in a separate expression, in a separate function, such as my func, that takes an argument x, and will return this entire expression here. And oops, it will be similar, and now as an argument I can pass, as the first argument I can pass my func here, right? So this one should have the same effect, but of course in this particular case using lambda expression is such nicer and more expressive. It looks like we are working with math symbols directly into the invocation of the function here, just like that. Alright, so this is another example. Perhaps we should implement this code from scratch another time. But for now, it's basically, I'm showing it how we are invoking it, and inside, and let's see also what's inside before moving on. And inside, of course, inside is very simple. At one point inside, if we are scrolling really carefully, no, I passed that line. So it's called fn. Let me locate fn. It's called fn, get function values. Right, at one point inside here, the function is invoked just by saying fn of x. If this wasn't provided as a parameter, would have been hard-coded something like this, sin of x. As a matter of fact, if we're running, if we put here sin of x in line 72, let's remember the line, is working fine. But now we lost all this ability here. Here we can put whatever we want. We can even we can even put an empty string. It will still display the sinus function. But if we are just parameterize it and allow to pass an expression here, well, in line 72, we don't have to actually hardcode what function we want to plot. We're just gonna invoke the one that is passed as an argument, which in this case is called fn there. So if we run it, we have the sign, and if we want another function, we'll pass another function. All right, so feel free to inspect yourself this example there. For now, in the interest of time, I want to move on and show you some built-in functions in the JavaScript library, built-in functions in JavaScript that accepts as arguments other functions, all right? And first function that I'm gonna show you is a function that allows to sort an array. And you probably will say, well, it's funny because yesterday or last lesson we just implement array sorting, and we're gonna touch on that one in a second. But JavaScript nevertheless has built-in support for sorting arrays. So let's take an array, array of numbers, typical numbers, -3, 100, kind of randoms. And how can we sort this one? So we want to basically, if we're gonna display the array here, of course it will be displayed all the numbers exactly like in the array. We want to sort it somehow, and then when we're gonna display it, we want to see it in ascending orders, like -3 being the first element, and the other elements being let me put different here, and in ascending orders. And the way we're gonna do that, we use the sort method on array. And sort will take some arguments, and I want to look together at the arguments. So we said when we want to inspect the built-in functions, it's always good to basically save sort and then go on and mdn. Mozilla Development Network is kind of the reference. It's a very good reference source for this JavaScript built-in functions. So remember this site for built-in for reference for the built-in JavaScript functions, and then MP5.js for the reference for the graphical functions. All right, so let me scroll really quickly here just to locate an example. Right, so the way it works is basically the function will sort the numbers, but will not sort them by default in ascending orders, like we build ourselves the bubble sort. It will actually ask to provide a compare function as an argument. And inside the compare function, the user of this function is the one that decides, do I want to sort in ascending orders, in descending orders, how I'm actually doing the sorting. Because with numbers it's pretty easy, right? We know for sure, and in all cultures on the entire globe, we know for sure that 2 comes before 3. Otherwise, math will not work anywhere. But with text, it gets more complicated, especially if text contains some diacritics using certain languages or some emojis inside. How do we sort smiling face versus versus heart or versus other emojis? Is smiling face coming first or the other one comes second? So as a user, we can decide which one comes first. So therefore, this kind of sort function accepts us to provide a compare function, which we basically can define it. And you can even notice here the syntax, either like an anonymous function like here, or like an arrow function that we saw today, or if you have it defined outside, you'll just provide it. The idea is that this function that you pass should take 2 arguments, and if the function returns a number greater than 0, then sort B before A. If it's less than 0, sort A before B, or 0. So all right, so let's basically sort here with the function, and let's pass an arrow function. Actually, let's write a function outside for the moment here. Function my comparer, or comparison, takes an A and B, and we can say inside if A greater than B, so the first number is greater than the other one, we can say return 1, right? Otherwise, we can have a -1. And let's pass this function here. And let's print again the array after we are passing this function. And let's see it. All right. We can see indeed that the array is sorted. As you can see here, the elements are in order. So let's look again at the comparer function that the sort expects. So first of all, sort it's basically a special method on the array. It's something that, or a special function if we didn't encounter methods until now on the array, and this one takes as an argument another function, which is this comparer function that we are supposed to write. And notice we said if the first number is greater than the second, return 1, meaning as we saw in the documentation, meaning okay, we need to sort them. Basically, we are sort B before A, so basically swap them. Right? So if we run it again, it sorts in order. But it's also up to us if we're gonna decide, we're gonna put here A less than B, we're gonna see that the function sorts numbers in descending order. So it's pretty interesting, right? Let's put them in ascending order like that. Sorts them correctly in ascending order. Now let's write this function as a lambda expression. And actually, we don't have to do this comparison at all, because if a number is greater than B, then A minus B will be greater than 0. So the way we can write this one, we can write it as a lambda expression like that, and basically return A minus B. Let's remove this one, or we can keep it. We can keep it as a comment. We don't need a semicolon here, and if we run it, also they are in order. So perhaps I write it a little bit more concise here, saying A. So this is a function that accepts A and B and returns the difference. So what will be the difference? Again, if A is greater than B, the difference will be greater than 0, which basically falls on this kind of expectation. Otherwise, will fall on the other one, so will happen differently. But nevertheless, as you can see, array sort, it's a function within the built-in JavaScript library, and this one takes as an argument another function, or expects a function, and us as a user of this function, if we want to sort numbers, we have to provide this one. If we are not providing it, well, it's not working as expected. But now it's working fine. So what can we do? Perhaps we should, let's sort this one, array sort. And let's actually bring in this exercise, in this code, the code that we wrote in the previous lesson with the bubble sort, and extend our bubble sort to also take this example, this kind of argument, right? So this is our bubble sort. If we'll run it again, let's run it here in place first of all. All right, we see that it's doing the sort of some numbers, but our bubble sort, first of all, it's a little bit different. It's not as a method on the array, but we invoke it passing the array. What we need to do is basically pass also a comparer function. So we should not have bubble sort in ascending order, but let the user of the function decide if it wants to sort in ascending or descending. So let's copy this function really quick from here, just the function. And if you want to see the implementation of how we did bubble sort, refer to the previous lesson here in the playlist. For now, we are interested on how to, let's clean up the code a little bit. We are interested how can we extend our bubble sort function to not sort in ascending order, but actually accept this comparer. So first of all, let's, and in order not to interfere, I'm gonna copy this one again. So this is array 2, this is array 2, we'll sort it using bubble sort of array 2, and then we print array 2. Let's print in between some separator, like that. So above is the array sort done with the one from JavaScript, and this one is done with ours. It still looks the same because it's sorting in ascending order, but how can we have this in descending order? So the way we're gonna do it, we go in bubble sort and we'll make it accept a comparer function. So let's say function fncomp, a comparer function, right? And we'll go inside here in the implementation, and instead of having hard-coded this expression, if a greater than b, we are actually reading the result of the comparer. So let's have result compare r, or result. We'll pass the a and b numbers to the comparer function that the user is providing. And now what we are doing here, we are checking if result is greater than 0. We basically swap them, right? So as a user, we are supposed to pass a number that is greater than 0, same as before, right? So right now we need to invoke this function here. If we run it like that, it should produce an error because we are not passing this argument. Let's see that. Yep, fncopy is not a function because here will be something undefined, and then when we're running undefined, it basically says undefined is not a function. But let's pass a function here, and you know what better other thing is than use the same function. So let's use it, this one. And now, okay, still performs correctly. It's sorting in ascending order, so the function worked. Let's try to inverse it. What if we have here b minus a? And let's have here as well b minus a, just to have a baseline and compare it. All right. The numbers are now sorted in descending order. And a minus b, and here a minus b. And you know, since we are using, by the way, since we are using this expression between two functions, of course this is just for a test, but I want to show you that we can also take it like we did before in a separate variable. So we can have here a conf, and this entire expression is basically this guy here, which is actually a function. So we are passing comp to both of these functions, and if we run it, we see it's in ascending order. If we want in descending order, we're gonna provide them in this way, and it's working as expected. So what did we see in this example basically? First of all, we saw how to extend our bubble sort with this kind of comparer function to make it similar in the way it works with the built-in JavaScript function array sort. All right. Let me save this one and share it with you on the chat. Array sort. All right. So perhaps before closing the lesson for today, we should just discover a few other functions that are coming with JavaScript, some built-in functions that also accept other functions as arguments. And these are also some very important functions as well. So let's quickly take an array, since all these are array functions that take other functions as arguments. Let's take an array, let's populate it with numbers 1, 2, 3, 4, 5, right? And another function is, or another method on this array is called for each. So let's write it. It's written like that, for each. And now what this for each accepts is basically takes a function as an argument. Here it will be a function, right? The function, the for each method of array will execute this function for each of the elements of the array, right? So let's write a function. Perhaps we should write a function print that takes a certain element, or takes a n as an argument. And what this one will do, we're gonna use println to type this one. All right, maybe you should avoid confusion. Let's name this one type. And type, we're gonna type it. We're gonna println the number, and now we should pass that function as an argument here. And let's run it. All right, we see the first 5 numbers display on vertical. So, and this is so simple. We can also put it inside here if we want. We can take the entire body and move it inside of type here. This one is working as well. We saw in the past that is working. And we can even remove the name of the function since it's not necessary and is still working, right? So this is like a kind of an anonymous function inside of array for each. And if you notice closely, what this is doing is basically replacing the for structure that the user would have to write, in a sense, because it's passing each number in an array through a function. So how can we achieve the same effect without this one? Well, very simply, we can write here a loop. Basically, we can loop through all the elements of the array, and here inside, now perhaps we can call a function. Now we remove that function, but we can call that particular function type of I in this particular case, or in our case we can just print directly the number. And these two should basically have the same effect, except not print I, print array of I, actually, because we want to print the elements of the array. And these two basically produce the same effect. So if you look between this kind of two codes here, or two snippets of code, this is more declarative in nature, how they call it. It's a fancy name, but let's write it above declarative. And this is what is called imperative. So these are fancy names, but imperative is basically the technique that used mostly until now. It's basically a very descriptive way of telling the computer what to do. It's basically, okay, saying define this variable, increment it, go with it till this value, and then do this thing. In the declarative approach, which we kind of didn't encounter until now, you don't describe how to basically iterate through the array. That's suppose it's encapsulated in this particular function for each. So perhaps deep inside the for each function, it's a for exactly like this one. But for us as a user, we just say, okay, we want to go on this array and have this expression executed for each element of the array. So we are kind of declaring what we want to do. And Here we are just scratching the surface because this declarative way is the basis of functional programming. It's a total new kind of methodology in programming. We'll not go very deep into that one, but nevertheless it's good to know about it. All right, so this is basically for each. Let's pick another method that exists here on the array. It's basically map. And let me name this one and share it with you. So this is array for each. Save it. And I'll put it on the chat. And let's see another useful method of the array, which is called map. So we'll have again another array. Let's use it the same array with the numbers 1, 2, 3, 4, 5. And map is similar to for each in a sense. It's written like this. It also takes a function here as an argument, and what we're gonna do, we'll basically process each element using this function, and the entire map method here, we're gonna return a new array. So basically we'll have an array2 here. An array2 that is basically kind of a copy or a clone of the first one, but actually is not copy in the sense that elements are not identical. Each element is passed to this transformation function, to this mapping function. So perhaps we can create a function as a mapping function, something that doubles the numbers, right? So okay, so let's write it here. Function. How can we write a function that doubles a number? We should care just about one number. Double number n, and this one returns n times 2, right? And if we pass as an argument double number here, map will run double number for each of the elements in the array and create array2 from that. So if we are printing here array2, and let's print above also array, we should see basically exactly like expected. The second array contains the same number of elements as the first one, but each element is the double of it. So, and that's because that's what array map is doing, is producing a second array where each element is basically passed through this function. So how can we achieve the same effect without this one? So without in the more imperative way. Now we have a new word in our vocabulary. So what we can do, we can very well define the new array, which is empty, and then we can go, let's say for each number of AR or first one, we're gonna push in the second one, we're gonna push, let's call this one double number of n, right? So if we run this one, we should see the same effect, but again, this one is done in a more imperative way, and the entire code here that we wrote is equivalent to this single line of code that is basically using the map function. But of course, the map function inside has a similar looping algorithm that goes over the numbers and runs the function for each number and so forth. And you know, it's okay if you want to write them in an imperative way. The main advantage with this declarative way, besides the being much shorter and so on, is that perhaps somebody, if it has to do a long processing, can implement inside of map a more optimized algorithm than we can do here. Perhaps can even split it across different processors and things like that nature. But anyway, that's beyond the scope of this exercise. For now, the main point is that this array map function takes as a function as an argument and is working as expected. But before moving to the next function, let's actually, because this one can be also written a little bit more concise in a way. So actually, let's comment this code all entirely here and have let AR2, supposing we just want to double the numbers, what we can write, passing here a lambda expression that takes an x and returns an x times 2. The variable, of course, doesn't matter. We can put an a and returns an a times 2. This is just the argument, or has an n, like with the same variable that you use here in double number, and returns an n times 2. And let's print AR2 like this, right? So this entire code, well, is 2 versions in here, but was resumed in just one single line of code using array map and passing this small arrow function expression here. All right, let's see, let's check this one with you. Array map, save it, and I'm gonna share it with you here. And you know, we can do all sorts of mapping actually, and it's pretty common in some libraries to actually map from numbers to strings perhaps, and we can do that as well. So you know, instead of this one, perhaps you want to map the numbers instead of doubling. Perhaps you want to name the number into something like this, number plus n. And if we run it, see the new array has this new strings in front, but all elements are numbers. But actually it's pretty useful technique when you're working with HTML, because you can map a number and place it between some, and we are not studying HTML here, but just as an example, between fancy tags such as list item elements. And in that particular case, this particular number will basically, you know, becomes a list of items, and these are just valid HTML tags, and you can do lots of things with them. So let's revert the example back to n times 2. That was a small parenthesis there, and again we have map. All right, one more function that I want to show you also that takes argument. It's also on the array. Only array functions we saw today mostly. It's filter. So let's name this one filter. So let's say we have the same array that takes 1, 2, 3, 4, 5, and let's say we want to filter this array and returns only even numbers, right? So the way we're gonna do it with a for loop, we know that version, we created in the past, we loop to the array, we check if the number is divided by 2, and then if it is, we put it inside of a second array and then return that array. So that would be the imperative implementation, but we can use the array filter method here that takes an expression that will basically let us decide when do you want to have an element in the second array. So array filter, it's similar to array map in the sense that it's returning us an array, but will return only the elements inside the first array that are passing a certain condition, and here is the filter. So this is the filter that will have to pass here. So basically we'll put as a filter n divided by 2 equal 0. Let's print ln ar2 like this, and if we run it, we see just number 2 and 4 because only these ones are even in this range. So if we put more, and if we put more, we see more even numbers here. So basically this is the same this condition here, or this filter is the same one that we also use if we want to implement this one in an imperative way. But of course this one is expressed very concisely. So what we have here, again, technically this is a function, it's an arrow function. This is a filter method on the array. This is a method on the array. It's an array object. I'm introducing this new terminology, but this one takes a function as an argument and will run it on each element and make a decision. If basically this one is true, then we'll include it in the second array. If not, we'll not include it. So that's how it works. I'm gonna share this one with you as well. And you know, if we want to implement ourselves a more complex filter, we can also do it ourselves. Either by just using this function, or if we just need a new filter, it's also easy to implement it using the same way that array filter is implemented inside the built-in library here. Array filter, it's on the chat. All right, so this concludes kind of the presentation for today. I hope that you had fun. It was a little bit more abstract kind of lesson. It's on the more advanced side as well, I would say. If you are not using this, you can very well create beautiful and complex programs even if you don't master this kind of concepts in the beginning. You can eventually mark the lesson optional and rewatch it again in the future once you are more prepared to work with these concepts. But anyway, I hope that you found them useful, and if you don't find them now, again, when you're gonna rewatch the lesson, you're gonna find it useful. We're gonna see tomorrow and discuss more about functions and objects, but until then I want to thank you for watching and say happy coding and see you next time.